Hello, Megan. Oh, hello, Megan, and whoever else might be watching. A couple of nasty questions at the back of the paper. Let's quickly go through them. Now, I quite like the look of both these questions actually, because whilst they are tough, they're both quite good fun. Okay, let's take this first one. I think most people will be fine on figuring out the area of the sector. Because I mean that's clearly just a third of a circle. How do I know it's a third? But it's 120 over 360, which obviously cancels to a third. And I've just got to multiply that by pi r, which is 10 in this case squared, and that's going to give me 100 pi over 3. Now that's the easy bit. That will probably get you at least one, maybe 2 marks out of the 5. So that's kind of nice. Now to get the other mark, you need a bit more. To get the other 3 marks, you need a little bit more thinking. Firstly, tangents from a common point are equal in length. And if I was to draw an attempt at a straight line here from B to O, that would clearly make the shape of a kite with two congruent triangles split in half. Now, at first glance, it looks like we haven't got enough information because it would be really nice if we knew the length of BO, because that means I could use a half AB sine C to find the area of this triangle, and then I could just double it to find the area of the kite, and then I could take off the area of the sector, and I've got the shaded region. So how can I find BO? That's definitely what I need. Well, you need to realize that tangents are also right angles to the radius, and then I can use, if I just reorient that triangle a little bit, that's the right angle, that's 10. This is the side I want, and I know that that's 60. So this is really now a SOHCAHTOA trig problem. I can now say cos 60 is adjacent, which is 10, divided by hypotenuse, which is x. Cos 60 is a half, so that means x is going to be 20. And now what I can do is use area of the kite. Well, that's going to be equal to 2 times a half times by 10 times by 20 times by sine of 60. And if you work that out, you could give it as an exact value, I suppose. Sine 60 is root 3 over 2. 2 times a half is 1. So you've got 200 times root 3 over 2. So that's 100 root 3. Okay, we can now work out the shaded area, because it should simply be the area of the kite, which is 100 root 3, minus the shaded area, minus the sector area, which is 100 pi over 3. And let's just work out what that is on my calculator. It's 68.4, three significant figures, 68.5 meters squared. And it's done. Okay, hope that one's nice and clear now. Let's have a look at something else. Let's have a look at 23. Now, yeah, this one is about geometric sequences. So let's just quickly talk about what makes a sequence geometric. A geometric sequence is something where you're multiplying by the same number each time to get from one term to the next. So, for example, that is a geometric sequence. And what characterizes geometric sequences are their first term, but also what you're multiplying by each time, which is often called the common ratio. Now, this topic is big in A level, so I'm really pleased you've asked me about this, because this is definitely great practice for A level. Great practice for A level. This comes up in A level all the time, and that's why this isn't going to stress me out too much. Now, notice with geometric sequences, if you ever take a term and divide it by the preceding term, you always get the same value. You always get the common ratio, yeah? So 6 divided by 2 equals 18 divided by 6, which equals 54 divided by 18, because they all equal the common ratio, 3. That is the principle I'm going to use to find x here. And it's also the principle I'm going to use in part B as well. So let's have a go at that. 1 divided by root x minus 1. That's the common ratio for this sequence. That's what you're timesing by each time. But that should also equal root x plus 1 divided by 1. And now I have an equation with just one unknown in it. So what I can do is just look at this part of the equation and try and solve it. So if I multiply the 1 over and multiply also the root x minus 1 over in brackets, I'm going to get that. I can now multiply out the brackets using a little grid like this. and I get x plus root x minus root x. That's nice, they cancel because it's basically difference of two squares, minus 1. So I get 1 equals x minus 1, and lo and behold, x is 2. Quite a nice little question, that, quite cute. Okay, now it wants us to show that the fifth term is 7 plus 5 root 2. Well, we need the common ratio for that, and as written above, the common ratio is, if you like, 1 over root 2 minus 1. But that looks a bit ugly, and I could also use root 2 plus 1 divided by 1, which is obviously just root 2 plus 1. And I like the look of that much more than 1 over root 2 minus 1. So I'm going to use that one, but I could have used either. Now, we already know what the third term is. The third term is root 2 plus 1. We're told that. So the fourth term is going to be root 2 plus 1 times by root 2 plus 1. And that's going to equal, if we do a little grid over here, root 2 plus 1, root 2 plus 1, we get 2 plus root 2 plus root 2 plus 1. And so that's 3 plus 2 root 2. That's the fourth term. For the fifth term, I'm going to have to times by the common ratio again. So I'm going to do 3 plus 2 root 2 multiplied by root 2 plus 1. Do a little grid maybe down here, just try and squeeze it in. 3 plus 2 root 2, root 2 plus 1. We get 3 root 2, and then we get 2 times root 2, which is 4. We get 3 times 1, which is 3, and then 1 times 2 root 2, which is 2 root 2. And sure enough, lo and behold, we get 5 root 2 plus 7. Okay, hope that made sense. Hope you're absolutely fine with that. Yeah, and it's a great question to get your head round because it is really similar to some A-level questions. So I hope it made sense. Okay, well done. Keep up the hard work and do have a look at some of the Maths Challenge questions as well because I think they're just as useful for developing you mathematically, even though they're not, you know, exactly like past paper questions. Well, actually, that's not true because they're perfect for practicing skills like this. You know, it's about what do you do when you don't know what to do. You know, when you're given a question which is in a completely unfamiliar context, the Math Challenge is great for that kind of stuff. Okay, anyway, I hope you enjoyed that, and bye bye.